Let's explore the fascinating world of waves and how they combine through superposition. Waves are everywhere around us, and when they meet, something amazing happens through superposition. First, let's understand what a wave actually is. A wave is a disturbance that carries energy from one place to another without moving matter along with it. Here's a simple wave showing its key features. Amplitude is the height, and wavelength is the distance between peaks. Every wave has three main properties: amplitude, which is its height, wavelength, which is the distance between peaks, and frequency, which is how fast it oscillates. We can describe a simple wave mathematically as y equals a sine of kx minus omega t, where a is amplitude. There are two main types of waves based on how they move. In a transverse wave, particles move perpendicular to the direction the wave travels, like ripples on water. In a longitudinal wave, particles move parallel to the wave direction, like sound waves compressing air. Now let's discover what happens when waves meet. The principle of superposition states that when two or more waves overlap, the resulting displacement is the sum of individual displacements. Mathematically, the total wave equals wave 1 plus wave 2 at every point in space and time. Here are two waves, wave 1 in blue, wave 2 in yellow. When they overlap, they add together to create the pink wave shown at the bottom. When waves align perfectly, something special happens called constructive interference. When two waves are in phase, meaning their peaks and troughs line up, they add constructively to create a wave with larger amplitude. Two identical waves in blue and yellow combine to create the larger pink wave. Notice how the amplitude doubles when they're perfectly aligned. In constructive interference, the total amplitude equals the sum of individual amplitudes. When waves are out of phase, they can actually cancel each other out. When two waves are exactly out of phase, meaning one's peak meets the other's trough, they cancel each other through destructive interference. Two waves with opposite phases, shown in blue and yellow, combine to create complete cancellation, resulting in the flat line in pink. When amplitudes are equal but opposite, the total amplitude becomes zero and the waves cancel completely. In real life, many waves combine to create complex patterns. Multiple waves of different frequencies, shown in blue, yellow, and cyan, combine through superposition to create the complex pink waveform. This is exactly how musical instruments work. They produce a fundamental frequency plus harmonics that all superpose to create unique, rich sounds. A special case occurs when waves reflect and interfere with themselves. Standing waves form when waves reflect and interfere, creating stationary points called nodes that don't move and antinodes that oscillate with maximum amplitude. Standing waves are fundamental to how guitar strings and organ pipes produce specific musical notes. Superposition in waves are everywhere in our daily lives. Noise-canceling headphones work by detecting outside sounds and producing waves that are exactly out of phase to cancel the noise through destructive interference. Radio and Wi-Fi use superposition to send multiple signals simultaneously by combining different frequency waves that can be separated later. Ocean waves are constantly superposing, creating the complex patterns we see at the beach from countless waves combining. Waves and superposition are fundamental principles that explain countless phenomena in physics, engineering, and nature. Let's summarize what we've learned about waves and superposition. Waves are disturbances that carry energy from place to place without actually moving matter along. When waves overlap, they combine through superposition by simply adding their displacements at each point. Waves can interfere constructively to create larger waves, or destructively to reduce or cancel waves completely. Understanding waves and superposition helps us explain everything from music and noise cancellation to ocean waves and radio communication.